Swayam Prabha. Digital India. Educated India.
So hi everyone, this is Praveen Poddar and I am working as a specialist BD for analytics in AWS. Today I am going to discuss a bit about modern data strategy and how AWS can help you in achieving this modern data strategy using AWS services. So let's start. So as I said, we are going to discuss a bit about modern data strategy. We are going to see how you can build a data architecture using AWS services, and then at the end, we are going to show you how to create a architecture using AWS services. So the one reference architecture, I am going to show it in my presentation today. So let's start. So now we are going to discuss a bit about modern data strategy. When we speak about modern data strategy in AWS, we generally say that it is based on three pillars: modernize, unify, and innovate. Now we'll go to these pillars one by one. Let's start with modernize. So when we say modernize, what happens that your data, when you are storing it or when you are creating a data platform, okay, most of the time we think more about infrastructure. Like suddenly a business problem come that you want to analyze. Let's take an example, okay. Let's say you want to see that what kind of traffic is coming in your platform or in your website, or what exactly people are searching in your website. Okay, there are a lot of e-commerce website available which generally checks like, okay, if certain person is buying an iPhone or any other phone, he might buy the phone case as well. So they are trying to improve their sales based on the behavior of buying pattern of a user. Okay, so what happens that to analyze this thing, generally what these company do, like they check like how much, what exactly you are clicking on their website. Okay, they gather those data and do perform some kind of analytics on top of that, and then based on that they decide, okay, I can show it like if some person is buying a mobile phone, that means later on he can buy a mobile phone case as well, right? So the thing is, now to have this kind of data, now just imagine like you have billions of users, or at a worst case just assume that you have millions of users, okay, and every second you are capturing those click stream data. So how big it can be, right? Now what happens in a normal case is that generally you think, okay, how I'm going to store this kind of data, whether my infrastructure can scale it or not, what kind of licenses I need to buy, whether my traditional relational database it can store this kind of data or not, whether I can analyze, whether I can analyze this data faster or not. Now the thing is like, instead of concentrating on this kind of business problem, generally people concentrate more on current infrastructure. So when you are building a modern data strategy, or you want to build a modern data platform, you have to, instead of thinking about your existing infrastructure, you have to think more about your business problem. And in order to do that, what you need to do is like you have to choose that data platform which can be easily scalable, okay, which can be trusted, which can be secure, okay. So rather than focusing on infrastructure, focus on business problem. Then second thing is unify. So in an enterprise or in any agency, okay, you have multiple application. It can be an ERP, it can be a CRM, it can be normal if we talk about edtech industry, okay, it can be an LMS. If you go to retail, there can be different different kind of applications are there in an enterprise. Now if you want to see the combined report, okay, then you have to unify all this data. And the problem with unify is like data can reside anywhere and in any format. So some data can be residing on cloud, some data can be residing on premise, some data can be residing on different private cloud as well. Now and some data can be on relational data, some data can be non-relational data, some data can be coming as batch data, some data can be real-time data. How you are going to unify this data? There can be different type of data, there can be different place of data, and in order to unify this data, you need those services which can easily take data in any format and from anywhere and push it to a data lake or a data warehouse. And lastly, which is innovate. So when we say innovate, means once you have data, what you want to do with that data? You might want to create some kind of a very good dashboard with that. You might want to expose an API for that data, so that other department, or you might want to sell that data as well. Okay, or it is possible that you might want to do some kind of AI ML model with that data. So it all depends upon your requirement, how exactly you want to consume that data. So these three pillars, first is like, don't think about the infrastructure much. Okay, choose that platform which can be easily scalable and trusted. Then you have to choose a data platform where you can easily unify all your data in one place, at one place. And then you need to choose that platform where you can easily consume your data, be it as a dashboard, be it as an API, be it AI model or predictive model. It's up to you or up to your business requirement. Now we'll discuss a bit about data architecture, how you can build the data architecture, and today I'm going to discuss like how AWS can help you achieving this modern data architecture. So when we say about a modern data architecture, so typically at a very high level we can say that generally in a modern data architecture you can have different type of data sources. It can be streaming data source, it can be a batch data source, data can be structured, data can be unstructured, and you need some service by which you can ingest it. And once you are ingesting the data, then you have to clean that data. So that means you have to store it in a landing zone, then you will be doing some kind of processing on top of that, and then that curated data will be there, by which once your curated data will be there, you need to do some kind of cataloging, and of course you can be consume that data using some kind of consumption service. And last not the least is how to secure and govern this data. So generally if we see the previous architecture, okay, so this modern data structure had generally 6 stages, or we can say 6 layers: data ingestion layer, data storage layer, data cataloging layer, data processing layer, data consumption layer, and security and governance layer. I will go to these layers one by one. We'll start with data ingestion, how you can ingest your data into your data platform. Now, when we are talking about this data ingestion layer, there can be different type of data sources. Your data source can be a relational database or can be a non-relational database. Your data source can be a file. It can be a plain CSV file or an Excel file as well, or even sometime EDI files, or it can be a different type of file. It can be an XML file also. Then there can be some data which you can be getting from some third-party data products, like SAP can provide you some data, Salesforce can provide you some data. So there can be different third-party data products which can be providing you some data. And then custom data sources are also there. So you have some custom application by which you want to get some data. And then these days we all knew like there are some IoT applications, like in manufacturing it's quite relevant, in retail it's quite relevant. So there are multiple places you can see like IoT applications are there, and those data can be streaming. So ClickStream can be a very good example for this, like those ClickStream is streaming to your data platform quite regularly. How you are going to ingest all these data sources or data into one platform? We'll start with the database data sources. I have presented 2 particular services here by which you can move the data into the data platform. Now please note that the destination I have mentioned it as S3 and Redshift. Now we'll discuss a bit about Redshift later on. So Redshift is our data warehouse, and when I am talking about this S3, please think that I am talking about a data lake. Okay, so S3 is a storage for our data lake. So just think that I am talking more about here data lake and data warehouse. Okay, so let's say you have a relational database. Okay, and you want to move that data into a data platform. And when we say data platform, so that means we are saying that we have to either move it to a data lake or to a data warehouse. How we are going to move it? So the first service which is available with AWS is AWS Data Migration Service, which we call it as AWS DMS. Now what it do, like, you know, whether your database is residing on on-premise or whether it is residing in any cloud, this AWS DMS can read the data and move the data to S3 and Redshift. Even this service can be used for, you know, replicating your data. For example, if let's say you have a SQL server here on the source side, okay, DMS can also move this data to a SQL server instance in AWS side, okay. But this session we are talking more about, you know, building a data platform or building an analytical platform here. So I will be concentrating more on moving the data to a data lake or to a data warehouse. So this DMS can help you do that. It's a true CDC kind of service. So that means first time it will be full load, and later on you can have, like, you know, delta load you can do with this particular service. And it will be a real-time service. So that means anytime this change will happen in your database, immediately, when I say immediately, the gap will be there, some, you know, 2-3 second or 5 second gap will be there, but you can move it to your destination. Now if let's say you don't have requirement of moving the data from your database to your data lake or data warehouse immediately, or if you want to do some kind of, you know, batch transformation or batch, you know, batch movement of data, so then there are different services available. I will be talking a little bit about AWS Lake Formation Blueprint. Okay, so another service is AWS Lake Formation Blueprint. I am going to speak about lake formation later on in my presentation, but there is a feature in lake formation service which we call as AWS Lake Formation Blueprint. Now what this service do, it can read the data. If your database is MySQL or Postgres, it can read the data and move it to a data lake. It cannot move it to a data warehouse, but of course a data lake, if you want to create, then lake formation can help you there. The good thing is, like, it will be a batch service kind of thing. So that means, let's say you have 100 tables in a database, behind the scene it will create 100 jobs, and all the data at certain you know, configured interval, it will move the data into the S3. Of course, in S3, in data lake, you can decide which format, in which format you want to store the data, be it a Parquet format, be it a ORC format, or you want to store it in a Hoodie catalog or anything. Okay, you can decide it here, but this lake formation can help you in this. Now, so one service was helping you in real-time migration, another service was helping you in batch migration. But please understand that both these service, you can move the entire database. But what if I say that you don't want to move the complete database, rather than you want to move certain table? Okay, so we have a service called Glue. What this Glue is doing here is that it's a serverless service. Behind the scene, Spark cluster is running. Okay, it can help you in ETL things. So there is a visualization layer on top of that Spark, which is built by AWS, which is kind of low code, you can say, okay, where you can drag and drop the thing and you can do your ETL very easily. Then if let's say you are a business analyst, you don't want to do any code, so we have another feature or another service in Glue, which we call it as a Glue Data Brew, by which you can prepare your data. You can do those basic and some advanced level ETL as well using Glue Data Brew. Okay, and of course with Glue you can also do the data replication, because it's behind the scene, it's a Spark cluster, and with by using that Glue visualization tool, what will happen that ultimately you are dragging and dropping those, you know, ETL things. Behind the scene it will generate a PySpark code for you. Okay, so of course Spark, you can do, using Spark you can of course do this data replication or do your ETL processing as well. Okay, so here in Glue also you can do the same. In fact, with that lake formation blueprint which I just talked about, behind the scene it is actually creating the Glue jobs only. Okay, so here you can do that data replication using Glue, and of course either if your destination can be a data lake, your destination can be a data warehouse, even your destination can be a normal database as well. So Glue can help you in achieving all these things. Okay, so in this presentation you are going to hear this Glue word multiple times, because Glue for us is not just a ETL tool. There are other features also available in this Glue, which I am going to talk later in this particular presentation. So moving forward to another data source, which can be a file. Your file can be residing at your on premise. Let's assume that there are some file which is available in your data center and you want to move it to the cloud. How you can move it? So we have our data sync service, in which we generally install a data sync agent on your premise, and then this data sync agent can copy your data and move it to the S3. Now there are SNO devices available as well. If let's say you have large chunk of data and you have some bandwidth issue and you want to not immediately, I would rather say, you want to move it to the AWS cloud faster. Of course, it can range up to 10 to 15 days. Okay, where we generally ship a SNO device to you. You can copy your data, and then once we will receive that SNO device, we can copy into to S3 or EFF or anywhere. Okay, please note that if you have huge chunk of data which will take months or lot of months or couple of months of time, then only the SNO device generally is used. Now moving into this SaaS application data. So we know, like in an enterprise, generally we know, like there can be a different ERP system, right? It can be SAP, it can be Dynamics, it can be Oracle, it can be anything. Okay, and if let's say you want to move those data into AWS, then we have a no code solution available, which is Amazon AppFlow. Okay, it's a no code solution. So that means you have to just configure your connection string, provided that your SaaS application have a connectivity with this particular service. What it will do, it will read the data and can move the data to S3 or Redshift. Okay, of course there can be other data destination as well, but today I am going to only talk about S3 and Redshift. Okay, so AppFlow is also there, which can read data from SaaS application. There are 100+ connectors available currently in AppFlow, and it is growing every year. Okay, and so if let's say you have data in SAP HANA, so Amazon AppFlow has SAP HANA connector which can read OData and can move to your data platform. Now this is very important, third-party data sources. Now let's assume, let's take an example of a retail store. So let's say that you in a Sunday, suddenly you see that the footfall is very low in a mall. Generally what we have seen, that on weekends or in weekends, footfall tends to get higher. Why? Because people have holiday and they want to visit or they want to go for shopping or go to movie with their family. But suddenly we realize that certain Sunday or certain Saturday or certain holiday, we don't have that much of footfall. Even in fact, it has actually decreased. Why? And if you want to analyze this kind of data and you want to understand the pattern, you might need a third-party data to analyze this thing. It may be possible that that day it was raining heavily. Okay, and so that's why people did not came out to visit mall. So how you will get those third-party data? So we have a service called Data Exchange. Now this Data Exchange is kind of a marketplace where you can buy data, or even if let's say you have data, you want to publish your data and you want to sell it, you can use this particular service. Okay, so let's say for example you want to buy some kind of weather data. Okay, and then you can use this service. This service you can directly push it to Redshift or a data lake. Even there are some API by which you can consume this data. So this Data Exchange is integrated with our data warehouse and data platform. So you can use this thing. Now last or the leaf for this ingestion layer is the streaming data. So let's think about a clickstream data or an IoT data, how you are going to ingest it in your data platform. So we have different services catering to different requirements for streaming data sources. So we have our own IoT platform, which is IoT Core. So if let's say you have IoT data, you can use IoT Core. We have Kinesis data. So if let's say you have video streams or you have textual data streaming, just assume like Kinesis, not Kinesis, like click stream data, then you can use our Kinesis services. And if let's say, and of course DMF, as we discussed in previous slides as well, that of course real time ingestion or real time migration of your relational data or database data, you can use the DMF. Of course DMF also supports some non-relational database like MongoDB as well. Then we have MSK Connect. So MSK Connect is nothing, just manage Kafka. Okay, so manage Kafka server is there, by which if let's say you have some application which is pushing or publishing data into Kafka, then you can use also this particular service MSK. Okay, now with this particular services, you can ingest data to Redshift or S3. Of course, OpenSearch service is there, which if let's say you want to create some kind of search engine or some kind of log aggregation, then of course this particular service can be used. Even these days this is also used as a vector DB. But yeah, so you can use these particular services for ingesting data to S3 or Redshift. So when I say S3, as I said, it is more about a data lake. Now, so now the first layer is done, we'll move to the data storage. So as I said, the data storage can be your database. Let's say for example, you have a data in MySQL residing on premise and you want to move it to AWS cloud. Of course, you can use DMF service or you can use Glue. Both way you can move the data. Okay, but today, as I said, like we are going to discuss more about a data platform from analytics perspective. Okay, so we will talk about the data lake or the data warehouse. Okay, so if let's say we are talking about this data storage layer, the first thing will be a data lake. So in my previous diagram, I have actually shown you like first it shall be there will be a landing zone, then you will be processing the data, and then there will be a curated zone. Now that curated zone can either be a data lake or can either be a data warehouse, or it can be a combination of both. These days we call it a lake house architecture, some data in data warehouse and some data in a data lake. Okay, so your storage layer can be a data lake or can be a Redshift if you are building a data platform. Now we'll discuss a bit about this Redshift stuff, okay, which is our managed offering for a data warehouse. So Redshift is essentially a columnar database. Okay, so all those relational database what you have heard till now, like MySQL, Postgres, SQL Server, Oracle, they are actually transactional database. Okay, they are row-based database. Now this Redshift is a column-based database. Okay, it's actually used for analytical purpose. So row-based database, just to highlight something like for everyone, is that a row-based database is designed for a transactional system where data records are changing quite frequently. Then a row-based database generally work better. But if let's say you want to have an analytical system, okay, so that means you are analyzing historical data and the data going to change bit lesser, like the frequency of changing will be bit lesser. So that's why we have seen like people wants to move data in a batch. Okay, then this columnar database or a big data or a data lake comes into the picture. So Redshift is actually storing the data in a columnar format. Now what kind of features with this Redshift have? Because it is actually storing data in columnar format, so that means the aggregation the analytical query will run faster in Redshift. Now there are few features which I want to highlight for Redshift. First is this, which is a spectrum. You can see here the spectrum. Okay, so just a few minutes ago I talked about a lakehouse architecture. So that means let's say you have some data which is stored in a data lake and you have some data which is stored in a data warehouse. Okay, if you want to execute a query which can get some data from Redshift and which can get some data from your data lake, how you can do it? So ultimately what will happen that your analytics app or your BI app will execute query on Redshift. Inside Redshift, there will be, some configuration for external table you have to do. What it will do, like, it will get data from Redshift table, and then it will create a spectrum query which will execute on your data lake, and it can give you a combined result. So what I mean to say here is that even if let's say your data is residing in S3 and Redshift combined, you can have a single query by which you can read both the data. Okay. Now, which data you will move to Redshift, which data you will move to a data lake. Okay. So there can be different design pattern for this. So generally, for example, we can say, like, if let's say you have 10 years of data and 2 years of data you are frequently using. Okay. So those frequent data you can move it to the Redshift, and some non-frequent data you can move it to S3, because generally storing cost of S3 is, bit lesser, and of course you can have different tiers of S3 by which you can again save the cost. Okay. So this way you can decide, like, which data you want to move to a data lake, or which data you want to move a data warehouse. Both way it will be fine. Okay. So we'll discuss something about federated query now. So let's say you don't want to move your data. Your data is still residing in your traditional database, which can be a SQL, which can be a Postgres, or anywhere. Okay, you don't want to move the data, or if let's say, because the data warehouse system are generally meant for historical analytics. It can be like you want some report for, like, let's say 30 minutes or 40 minutes, data which is like committed in the system 30 or 40 minutes before, then Redshift will give you better result. But if let's say you want to do some kind of real time analytics, okay, or if you can't move the data, okay, then you can run those federated query using Redshift. So that means the query will be fired in Redshift, but ultimately inside Redshift, this Redshift will query your operational database. Then of course there is another feature which I want to highlight is ML and analytics. So there is a feature as a Redshift ML available in Redshift. So you can create those ML model writing those SQL statements. So you might not need to have those Python skills to create those models. Okay, what you can do, like, you can just write like create model this kind of a statement, and then it will create a model for you, analytics model for you. And then of course there are certain set of algorithm which is available in Redshift. Based on that you can create those model, and because your data is already residing in Redshift or in data lake, it can train that data based on Redshift data or your data lake data. And then of course after that, once the data model is trained, that inference part means once the prediction part will be there, it can be deployed on your Redshift cluster itself, saving your cost. Okay, you don't need a separate cluster for that. Of course, that decision you have to take, but this is also possible with Redshift. And there are other features which are coming in Redshift. One is like the zero ETL feature. For example, if let's say your data is already in Aurora DB. Aurora is our database for Postgres and MySQL, which is a cluster. Okay. And if you want to move it to the Redshift, you might not need any separate ETL service like Glue or DMS for that. Going forward, you can directly move it to the Redshift. So we are generally going towards that zero ETL kind of feature right now. So currently, this Aurora Postgres and Aurora MySQL zero ETL feature is available. Okay, I need to check, like I believe that this is not available in India yet, but it will be sooner or later, it will be available in India as well. Now, for data storage layer if done, what about data cataloging? So the third part is data cataloging. So data cataloging is nothing, how to make sense of the data. For example, our mind is trained to see the data in a relational format. We don't know how generally, I mean, most of the people don't know how internally Oracle or let's say Postgres or let's say SQL, for they are storing the data, but how generally we visualize, like, we generally query it in a SQL statement, and then what happens that we see the data in a tabular format. Okay, behind the scene, whether they are storing it in a file format, whether they are storing it in a certain different format, most of the people don't know it. Okay, so generally when we say cataloging, so means like how to visualizing it in a certain format, be it a relational format. Generally our mind is trained like that. Okay, so for Redshift, generally you create the table structure first, and then of course you are inserting the data. For those table or those schema, you can consider it as a data catalog. But what about data lake? So you have data in S3, but how to make, how to use those data. Okay, so you need to have a relational structure on top of that. How you will, you are going to create that. So remember I told you that I am going to use this glue word again and again. So here again, this data catalog we build on top of glue. So glue is not just about ETL, it also have a feature for data catalog. By default, this data catalog will be built on Hive. Okay, when we say Hive, so generally Hive data are immutable, so you cannot change it. But Glue data catalog also supports Hoodie, Iceberg, you know, those data catalog which can be, you know, which can have those AFIT transaction as well. Okay. So Glue, by using Glue, you can build a data catalog on top of that. And generally, you know, like you are, if you are building a data lake, you are storing data in S3, so that means your cost of storing will be very less. Then if you are building this data catalog using Glue, okay, so generally it costs you less than, you know, $2-3 for 1 million object for a month. Okay, so we can definitely check the price, but of course it's quite less. Okay, so cataloging your data don't take too much of too much of cost on AWS, and you can choose your format, whether you want a Hive format, whether you want what you can say Iceberg, or whether you want a Hoodie format. You can use this data catalog, Glue data catalog feature. So of course, one side of the spectrum is actually Redshift, which is our data warehouse. The same thing, you can build a data lake also. Again, the data will be stored. The data you can store it in a columnar format. Columnar format is also possible in a data lake, which can be a Parquet or can be an ORF. And then on top of that, you can build a AFIT data lake, which can be Iceberg data lake or which can be a Hoodie data lake using Glue. Now, so data processing layer. So of course, you have ingested the data, and now you want to do some kind of cleaning. How you can do that cleaning? Okay, so we have services called EMR and Glue. I have already discussed a lot about Glue right now, that it can be used as an ETL service, it can be used as a catalog. Apart from that, it has its own visualization tool as well, by which, you know, if you don't want to write code, you can do those drag and drop things, and you can create those ETL pipeline. But if let's say you are a geek and you want to write some code, PySpark code, then you can also use EMR services. Okay, so EMR is nothing, just a managed Hadoop. Okay, and of course in managed Hadoop you can install Spark, and then you can run your Spark code on top of that, and then of course you can process your data. And the destination can be anything. It can be your S3, it can be your data warehouse, even it can be your, you know, normal database as well. Even if you can send the data to OpenSearch as well. Moving ahead, so with AMR, so now you already have an ETL tool. You already know how to ingest the data, you know how to catalog the data, you know how to process the data. But while processing, there can be a business problem as well. Like let's say you have 20 table or 30 table, okay, and you want to move the data in a certain sequence. Or let's say you have a problem that you are ingesting a data into a table, and then you want to do some kind of work, and then after that only that another job you want to run. Okay, how you are going to orchestrate this thing? So there are a couple of services which is provided by AWS. First one is Amazon Managed Workflow for Apache Airflow. It's just a managed cluster for Apache Airflow. If you want to go for an open source thing, then you can go with this thing. Of course, there will be a cost associated with this. Another one is step function. So if let's say you are using AWS native services and you want to create some kind of workflow, you can create using AWS step function. We will discuss about data consumption now. So data consumption, when we talk about data consumption, of course, you can consume it via AI/ML models, you can consume it via API, and you can consume it via your BI tool. I will discuss a bit about our BI tool, which is QuickSight actually. So let's say you have a business problem by which you want to embed your report in your application. And if let's say you have a multi-tenant solution and you want to expose the data set and you want your tenant to create the report themselves, okay. and let's say, you know, you want to run some kind of NLQ query, okay, in just like English statement, then how you can do it? So our QuickSight solution provides all these things in a one service, okay, and it is priced based on user. So there is a price for author who is creating the report, there is a price for a reader who is reading the report, and the good thing is like reader price is session based. So let's say NLQ feature is not enabled and you have a reader, so it will be priced like 30 cents per session. So when we say 30 cents per session and it is capped at $5, I'm talking about, you know, something which is when NLQ is not enabled, and it is capped at $5. So that means, let's say if a user is reading the report 3 times or 4 times, okay, so he will be charged like, let's say 3 times he is reading the report, so that means only 90 cents will be applied, cost will come. But if let's say if a frequent user is coming and every day he is opening report 10 times, okay, 300 times or 400 times or even 1000 times he is opening the report in a month, then the maximum it will charge you $5 per month, okay. So that is for, you know, named user, of course the user who is you know, registered with QuickSight. But there is a possibility that you want to build a public dashboard, okay, where you don't know who the user will be there. So capacity pricing is also available with QuickSight. With QuickSight you can do 100% white labeling, so it's just like drag and drop thing. It has in-memory computation available as well. Up to 1 terabyte you can pull the data into QuickSight memory, and it can do like, you know, in-memory calculation, and which will be very fast. It is possible with QuickSight. So now the data consumption layer is completed. So I'm not going to talk a bit about AIML. Of course, we have different service for AIML as well. I'm not going to talk about API. Of course, you can create some kind of microservice, or you can create your GraphQL API on top of, you know, on top of your data layer. But yes, there can be different means by which you can consume your data. Lastly, it's security and governance. So I told you like I am going to come back to this lake formation service. So lake formation is a very important service for us, okay, by which you can create a data mesh architecture. So that means you have different department, and each department want to share the data with the data platform. They want to put some kind of restriction what data they want to share, you know, and there will be a consumer who will be consuming the data. Certain consumer, you don't want to, you know, access certain data. So that kind of, you know, that kind of restriction you can put using lake formation. Of course, lake formation has a feature called blueprint by which you can ingest the data. Lake formation, you know, can provide some kind of can put some kind of, you know, restriction on the data, like which data will be accessible to whom. You can share your data to different account as well using lake formation. You can put your security rules. So there are other services as well by which you can go on the data. For example, backup is there. If let's say you want to do some kind of business continuity, then backup is there. If you want to do the auditing, CloudTrail is there. You want to see error log, CloudWatch is there. And if you want to secure your sensitive data, then Messi is there. Okay. So as I said, there are different services which can help you in doing those you know, security and governance compliance for on your data. Lake formation, as I said, you can do multiple things with lake formation. You can create a data mesh architecture with lake formation. You can put some kind of restriction on data, like, you know, which data will be seen by which one, you know, some department. If you want to put restriction, you can do that thing with lake formation. And of course, there are different services like AWS backup is there. If let's say you want to do backup data at certain interval, you can use AWS backup. If you want to audit your data, of course, you can use CloudTrail. You want to see the error logs, you can use CloudWatch. If you want to secure your sensitive data, if you want to hide those data, you can use Messi. So there are different services available in AWS by which you can govern your data. So we'll skip this slide. Now last is the reference architecture. So if you see this architecture, okay, so you can have multiple data sources. You can use DMF, data sync, Kinesis services, or Kafka or IoT Core or Airflow. You can ingest the data in S3. Of course, you can use lake formation to govern the data. And then once the data will be here, then you can process the data using Glue or Databricks. You can also put an EMR here. And then once the data is processed, either the destination can be your Redshift. It can be even a S3 data lake. You can consume it via QuickSight. You can move it to the open search service. Okay, if you want to create some kind of search engine, you can do that. And of course, you can consume it via ML models as well. So you can do all these things using AWS data frame. So this is just a reference architecture. Of course, you can have a different architecture. Depends upon your business case or depend upon your business case complexity. The architecture can be different, but in a nutshell, this is kind of a overall architecture for building a data architecture on AWS. With this, I'd like to finish this presentation. Thank you very much.